My name's Marin. I'm a Reality Kit Tools engineer, and today I want to introduce you to a brand new feature in Reality Composer Pro called Timelines, which provides a new interactive way to make your 3D content come to life. Last year, we announced Reality Composer Pro to make the process of previewing and preparing 3D content for your apps easy. It consists of a visual editor to let you compose your scene, organize your assets, add interactivity, physics, or even fine-tune the look of materials on them using the shader graph editor. There is a whole lot you can do with Reality Composer Pro. If you're new to Reality Composer Pro or just want to get a refresher, I highly recommend you go through these sessions from last year's WWDC. Reality Composer Pro lets you visually design, edit, and preview Reality Kit content. You can compose scenes, configure components, create complex materials, add audio, and much more, all in one place. This year, we've added new features to help you create animations using the timeline editor, add lights, and help you with environment authoring. In this session, we'll focus on the timeline editor. I'll show you how to build an interactive app using timelines and some new animation APIs in Reality Kit. Let's take a look. You might have seen the Botanist app in some of the other sessions. Let's take the robot from that app and reboot it to make an interactive virtual experience of our own. In this app, we have 3 plants that start to wilt. If the plant is wilted, I can tap on it, which triggers the robot to move to the plant and water it. The plant slowly becomes healthy, and the robot goes back to the center of the platform. There's also a second robot watching a butterfly, trying to reach out and touch it as it's moving. You can download the sample project linked to the session to follow along. To build this app, we'll start by moving the robot to the plant using timelines in Reality Composer Pro. Then, I'll show you how to utilize Reality Kit's full-body inverse kinematics system to make the robot reach out to water the plants. After that, I'll walk you through how to write animation actions in code, which we use for rotating and moving the robot back to its starting position. Next, I'll show you how we animated the plants using blend shape animation. And last, we will add a skeletal pose animation for the second robot watching the butterfly. Let's start with an introduction to timelines. Timelines is a brand new feature in Reality Composer Pro that allows you to sequence actions to be executed in a particular order or at a particular time. Reality Composer Pro allows you to easily edit and configure those actions. On the left panel is a list of all the timelines. The center is the main timeline editor, and the right panel is a list of all the available built-in actions. Once you've created a timeline, you can initiate the timeline to play based on a trigger. Let's take a look at our first animation. In our experience, when I tap on the plant, it triggers the robot to spin and move towards the tapped plant. Let me show you how I built this timeline sequence. Here in Reality Composer Pro, I have a new tab in my bottom panel called Timelines. In the center, there is a Create Timeline button. I'll go ahead and select that to create a timeline. On the left-hand side, I have a list of all my available timelines, and in the center is my main timeline editor. This is where I can configure my actions and sequence them on a timeline. On the right-hand side is where I have a list of all my pre-built actions that I can easily drag and drop onto my timeline. Let's rename our timeline Move to Poppy. I'll select the timeline, double tap it, then type Move to Poppy. First thing I will do is have the robot turn to face the tapped plant. For this, I will use a spin action from the list of pre-built actions. I will drag the spin action onto my timeline. I want to make my robot spin, so under the target field in the inspector panel, I'll select Choose. And then find my robot entity in the hierarchy or the viewport and select it. When I am done with my selection, I will tap Done. Now let's configure how much the robot will spin by setting the revolutions in the inspector panel. Let's set it to 0.12. I don't want to spin a full rotation, just a slight turn. Let's see what this looks like. There's a play button in the top of my timeline editor. If I tap on that, I can see a preview of what my action's going to look like. Cool. I can see the robot turns and it looks like it's facing the plant. After it spins, I'm going to make the robot move. For this, I will use a Transform To action. I'll grab a Transform To action from the list of my pre-built actions and drag and drop it onto my editor. I'll sequence it to happen about a second after the spin action. I'm going to target this action to my robot because I want to make the robot move towards the plant. So I'll select Choose and find my robot in the hierarchy. Then tap Done. Now I can see a visual cue of where the robot is going to move to. Currently, it's on the center of the platform, which we don't want. So let's go ahead and use the manipulator to move the robot's destination right in front of the poppy plant. All right, I think that looks pretty good. Now let's change the duration of the transform action. I'll change it from its default duration of 1 second to a larger number. This will make the robot take a little longer to move to the plant. I can do this by dragging the trailing edge of my action in the editor. Or I can set the duration in the inspector panel. I can drag actions and move them from one track to another. This allows you to sequence multiple actions to run simultaneously. I'll drag the spin action onto a new track that I'll use later. Now let's preview this to see what it looks like by tapping the play button. All right, I think it looks pretty good. It would be nice to give the robot an animation and audio while it's moving toward the plant. To do this, I'll create another timeline, which will coordinate the walk animation and audio to go along with it. I'll tap the plus button in the bottom of my timelines list. Let's rename this timeline Robot Move. I'll select the new timeline and double tap it, then type Robot Move. To have an animation and audio play, I'll use two new components, an animation library component and an audio library component. Let's take a look at these two components. An animation library component is used to store and associate animations with an entity that will play them. You add an animation library component to a rigged entity, and then add animation resources to the animation library component. Reality Composer Pro makes it easy to add animations into the animation library component. You tap on the plus button and select the animations from your project. This adds the animation resource to the animation library component on that entity. You can then use this later for playing animations in code or using timelines in Reality Composer Pro. The audio library component works very similarly to the animation library component. An audio library component is used to store and associate audio resources with an entity that will play them. You add an audio library component to an entity, and then add audio resources to the audio library component. To add audio resources into the audio library component, you tap on the plus button and select the audio files from your project. This adds the audio resource to the audio library component on that entity. You can then use this later for playing audio in code or using timelines. Let's go back into Reality Composer Pro and finish adding the audio and animations to our timeline. On the Robot Move timeline, I'll add an animation action using the new animation library component. I've already added a USD animation to my project browser, which I'll use. To do this, I'll select the robot in the hierarchy. In the inspector panel, I can see that an animation library component has already been added for me. This is because this entity has a USD animation already associated with it. Reality Composer Pro automatically adds the component for me and lists its default animation in the animations list. I can also add an animation library component manually by selecting the Add Component button at the bottom of the inspector panel. If I select the default subtree animation, I can preview the animation using the play button or slice it into clips using the scissors icon. This animation is a little longer than I want, so let's slice it into 2 clips, a shorter beginning and end animation that I'll play back to back. To do this, I'll grab the playhead and drag it to where I want to make my first slice. Then I'll click the scissors icon. This creates 2 clips. Now let's make another slice so I can use just the ending. I'll drag the playhead again to where I want to make the second slice and click the scissors icon. Great, now I have 2 clips that I can play back to back. I'll rename the 2 clips Start and End Block. Now I'll select the robot move timeline so that I can sequence the animations back to back. I'll grab an animation action and drag it onto the timeline. I'm going to target the action to my robot, so I will select Choose and then pick the robot in the hierarchy. Then set the animation to the Start Walk clip. I'll drag another animation action onto my timeline for the second clip. I'll have the animation run immediately after the first. I'll also target the action to the robot and set the animation to be the End Walk clip. While the animation is running, I want to play an audio clip at the same time. To do this, I will use an audio library component and an audio file I've already added to my project. Let's select the robot in the hierarchy. I'll add a new component by selecting the Add Component button in the Inspector panel and pick Audio Library Component from the list. I'll tap the plus button and find the audio files needed. I'll add 2 files, one for the robot turning and one for the robot moving. Now let's go back to the robot move timeline and set up when the audio action should run. I'm going to drag an audio action onto the timeline. I want the robot to emit the audio sound, so I will select the robot as the emitter. And I want it to play the audio walk clip that I just added, so I'll set the audio resource to be walk. Then I'll drag the audio action so that it plays at the same time the walk animation runs. All right, let's play this now. Great, the animation and the audio played together. Now I'm ready to use the robot move timeline in the Move to Poppy timeline. Let's select our Move to Poppy timeline. Then I'm going to right-click on the robot move timeline, and I will select the Insert into Timeline option. This will insert the robot move timeline into the Move to Poppy timeline. Now I have a timeline playing inside of another timeline. I can go ahead and move this nested timeline to any spot by dragging. I'd like to have the animation occur right after the spin finishes. And I will pair that with the transform action so the animation and the transform occur simultaneously. I'll change the duration of the transform action so it starts moving a little bit after the animation starts and stops moving a little bit before the animation finishes. And I'll add an audio clip to play when the robot spins. I'll drag an audio action from my list of pre-built actions and place it to happen along with the spin action. I'll set the robot to be the emitter and the audio resource to be the rotation audio. Let's go ahead and preview this to see what it looks like. Awesome! The robot is moving to the plant with an animation and audio playing. Now that we've created our timeline, how do we initiate the timeline to start playing? Well, there's one of 2 ways we can do this. We can either, in code, use the RealityKit API to call entity.playAnimation on the animation resource instance for the timeline, or we can use Reality Composer Pro's UI to add a new behaviors component, which will initiate the timeline and start playing without writing any code. To use Reality Composer Pro to initiate a timeline to play, you need to add a behaviors component to the entity you want to trigger the timeline. We have a few different types of triggers that can be used to initiate a timeline to play, such as tap, collision, when the entity is added to a scene, or based on a notification you post in code. Let's jump back into Reality Composer Pro to set up a tap gesture on the plant to initiate the timeline to run. To set up the tap gesture, I'll start by selecting the plant that I want to tap on. In this case, I'm going to select the poppy plant in the hierarchy. I'll add a new component by tapping the Add Component button in the Inspector panel and find the Behaviors component. Then I can tap on the plus button and select the tap trigger because I want the plant to respond to a user tapping on it. When I tap on the plant, I want the tap gesture to trigger the Move to Poppy timeline to play. So I will select the Move to Poppy timeline in the list. Now we need to tell the Reality View to respond to tap gestures. So let's go into Xcode. On the Reality View, I'm going to add a tap gesture. The tap gesture will be targeted to any entity. At the end of the tap, so when you lift your finger, we're going to get the entity from the value passed to us and apply the tap behavior to the entity. What that means is when I tap on the entity, in our case it will be the poppy plant, I'm going to apply the tap behavior that I specified in Reality Composer, which is the Move to Poppy timeline. I can now build and run to try this out. Let's tap on the poppy plant and see what happens. Great! When I tap on the plant, I see the robot turn and move to the plant. We've successfully created our first animation and initiated it to play based on user input. That's pretty cool. Now for the second animation after the robot arrives to the plant, I want to have the robot reach its arm out to the plant. What I will do for this is add a notification action and listen for the notification action in code. When the notification fires, I will then write some custom code to have the robot reach out to the plant. Let's go back into Reality Composer Pro and add a notification action. From the list of pre-built actions, I'll drag and drop a notification action onto the end of the timeline. I will target this notification action to be the poppy plant. Then I'll set the identifier of the notification to be reach to poppy. This string is what will be passed to us when the notification fires. Now that we've set up the notification in Reality Composer Pro, let's add the code to listen for this notification in the immersive view. Back in Xcode, on the immersive view, I will add the notification name reach to poppy. Then add a publisher for the notification. Next, I will handle receiving the notification on the Reality View using onReceive. When I receive the notification, from the output, I can grab the source entity off the user info dictionary and then write some code that will initiate the robot to reach out to the plant. Let's take a look at what the reach animation should look like. When the robot arrives at the plant, I want it to reach its arm out. To achieve this, I'll use RealityKit's full-body inverse kinematics system. Inverse kinematics is the use of kinematic equations to determine the motion of a joint in a rigged skeletal structure to reach a desired position. You specify the target position and any constraints on the affected joints. The intermediate joint positions are calculated for you. A common example of this is moving a hand to a desired position and having the elbow automatically adjust to reach that position. You can use this to achieve natural-looking movements for characters. I'll explain the new Inverse Kinematics API through a schematic diagram and then show you how to use it in code. First, I will instantiate an IK rig. The IK rig defines how the Inverse Kinematics solver should work. I'll give the IK rig the model skeleton and a configuration, such as the number of iterations. If you're playing an animation on the same entity, then you need to give weights to the animation and weights for IK so the solver will know what to override. I will then add constraints. Constraints are limitations on how the joints can change. This can be used to prevent unnatural movements, like bending an elbow in the wrong direction. Then I'll create an IK resource from the IK rig we defined. The IK resource is the runtime data that the IK solver uses for processing. I'll create an IK component from the IK resource. Add that to an entity. You can set up the solver on instantiation of the component and update it at runtime, as often as every frame. It's important to note that RealityKit's IK solver will solve over the full character skeleton simultaneously, and not just on a subset of the joint hierarchy. Let's write the code using inverse kinematics to have the robot reach out to the plants. To set up the inverse kinematics solver, I'll start by initializing an empty rig, passing in the model skeleton. Then I'll update the global rig settings. With some trial and error, I found that setting the max iterations to 30 and the global forward kinematics weight to 0.02 looked best. And I'll reference the joint names on the rig skeleton. In this example, we need to move the robot's hips, chest, and hand to have a natural-looking animation of the robot reaching its arm to the plants. Then I'll define constraints for the rig. This example sets up two parent constraints and a point constraint. A parent constraint constrains a joint's position and orientation. A point constraint constrains a joint's position. Next, I'll make a resource containing the rig and add an IK component with the given resource. To update the IK target on every frame, I will find the entity in the scene and position it. First, I'll get the position where the hand should reach. The position should be relative to the entity that has the IK component on it, and change the X, Y, and Z position of the reach position so that it's slightly different each frame. I also want to update the constraints for the left hand on each frame, so I'll get the IK component from the entity. Set the left hand target translation and position of the left hand. A value of 0 means IK has no influence on the constraint, and a value of 1 means IK has full influence on the constraint. To smoothly animate the robot's arm when beginning and ending IK, I increment and decrement the weight of how much the position is driven by IK and how much it is driven by the base pose over time. Then, commit the updated values to the component. Let's run the code to see how this looks. Nice! We reached our goal with that animation. After the robot reaches its arm, I use a particle effect to water the plants. Now that the robot has finished watering the plant, let's make the robot return back to its starting position. For this, we'll use animation actions. Animation actions allow you to set up when actions occur and sequence actions together over a duration of time. This is similar to a cutscene animation in a game, but with animation actions, you can do this in real time. A common use case for this would be footfall events when a character is walking. Every time a character's foot lands on the ground, it makes a sound. Let's use animation actions to move the robot back to the center of the platform. The Actions API has built-in actions and a custom action. The built-in actions consist of a number of pre-built actions that you can easily configure, like spin action or play animation action. This is the underlying API that supports the timelines feature in Reality Composer Pro. If you have a need outside of what the built-in actions cover, you can use the custom action. This allows you to write your own action in code and have it synchronized on a timeline. To use the built-in actions API, you will first create an animation definition for an entity using a built-in action. Then, you'll create an animation resource from the definition. Group the animation resources that you want to play at the same time, and sequence the animation resources to be played in a certain order. Last, you will call play animation on your entity. Let's check out how to do this in code. I have a few methods that contain logic in them, which define the animations and return animation resources for rotating, moving, and aligning the robot. The logic for these animation resource instances has been defined using existing RealityKit APIs. I'll sequence these animations together, starting with a rotate animation, followed by a walk and move animation, then an align at home action, and finally the robot travel home complete action. Then I'll start playing these animations in that order using the existing Play Animation API. For custom actions, you will first create your own protocol conformance of an entity action. Then you'll create an animation resource from it using the Make Action Animation API, and group the animation resource with others or sequence it to be executed in a certain order. Last, you will call Play Animation on your entity. Then at runtime, you can subscribe to start and end events for the custom actions. Let's see these steps in code and make our robot return back to its starting position once it's done watering the plants. I'll create a custom action named Robot Move to Home Complete, which I'll use to notify us when the Move to Home procedure completes. Then, create an instance of the Robot Move to Home Complete entity action. Generate an animation resource from it using the Make Action Animation API. One thing to note is that you can sequence or group multiple animations with a custom action. Since we only have one animation here, we won't do any sequencing. And play the animation resource using the Play Animation API. I subscribe to events when the entity action has started. The subscription closure will be called when the action starts. When the start event fires, we know the robot has arrived at its home destination, so I will stop the playback controller to stop the animation. I also subscribe to events when the Robot Move to Home Complete entity action has ended. When the closure is called, I transition the robot to the arrived home state. Now, let's run this animation sequence. All right, we're on a roll now. Let's focus on the plants animation. For this, I'll use Blend Shape Animation. Blend Shape animations allow you to smoothly transition from one pose to another, creating lifelike movements. These are commonly used for animating a character's face or body by blending between a series of different shapes. For our example, I'll animate the plants from a wilted to a healthy state and vice versa. The Blend Shape Animation API consists of a Blend Shape Weights mapping, Blend Shape Weights component, and two ways to execute the animations, procedurally or via USD animation. The Blend Shape Weights mapping allows you to set a weight associated to a blend target. You set up the blend targets on an entity, and each target can have weights associated to it. You can set a weight from 0 to 1. In our case, the weight of 1 is a wilted plant, the weight of 0.5 is an in-between state, and the weight of 0 is a healthy plant. To animate the plant from wilted to healthy, I'll update the weight value over time. To use the Blend Shape Animation API, first I'll define the Blend Shape Weights mapping. Then I'll create a Blend Shape Weights component from the mapping and add the component to an entity. Once the component is on the entity, I can query the Blend Shape Weights component or the weight values and update them at any time. I'm now able to procedurally create either a from to by or sampled blend shape animation. Or I can play a USD blend shape animation using the existing Reality Kit Play Animation API. Let's walk through creating this in code. First, find the model entity that has the model component from the entity hierarchy. Get its mesh resource and create the Blend Shape Weights mapping from the mesh resource. Then, create the Blend Shape Weights component from the mapping. To update the blend weights at runtime, I will get the Blend Shape Weights component from the entity. Get a copy of the Blend Shape Weights set so I can assign weight values into the set. Update all the weight values by blend weight index in the Blend Shape Weights set and set it to 0, which indicates a healthy plant. In this case, we are setting the state of the plant to stay at a healthy state. To transition from healthy to wilted, you'll gradually increment or decrement the value with an easing function. Then, assign the new weight values to the blend shape weights component so they will take effect. Let's run the code and wake these flowers up. It's so nice to see our flowers bloom back to life. Now, let's check out what our second robot is up to. The robot is reaching its hand toward the butterfly using inverse kinematics. The butterfly is flying around using an animation action created in Reality Composer Pro using a timeline and a custom component modifying the butterfly's position. If we focus on the robot's head, we can see the head is following the butterfly's flight path. To achieve this movement, we will use the new Skeletal Poses API. A typical rigged 3D character consists of a skeleton structure that is made of interconnected bones. Each bone corresponds to a different part of a character or object. To animate the character, you rotate its joints to pose the object into various positions and animate them. This is commonly used for making characters walk or run. The Skeletal Poses API adds a new Skeletal Poses component. You can use an animation produced by RealityKit, or you can modify the skeleton at runtime with an interface to programmatically query the Skeletal Poses component or a specific joint and update the transforms on it. We will use the Skeletal Poses API to make the robot's neck bone rotate as if it's watching the butterfly flutter around. Any skinned mesh that's imported into RealityKit from a USD file will already have a Skeletal Poses component attached to the entity, so we don't need to initialize it. Just grab the Skeletal Poses component from the entity. Update the rotation of the joints. It's important to note that this is in local space. To have the neck rotation update on every frame, I will call this code from RealityKit's update function. RealityKit calls the update function on all registered systems every frame, and commit the updated values to the component. I can update the entire joint transform, or just the translation, scale, or rotation. This can be updated at most every frame. Let's run the code and see the robot look at the butterfly fluttering around. Well, I don't know about you, but that one made my heart flutter. We've covered a lot today. Let's recap everything we talked about. We learned how to use Reality Composer Pro's timeline feature to sequence actions on a timeline and initiate them to play with triggers. We made the robot's arm reach out to objects using the new full-body inverse kinematics API. How to use built-in and custom actions to sequence actions together. We looked at how to blend between a series of different shapes using blend shape animation. And we saw how to animate an object by rotating the joints to pose the object into various positions and animate them. In addition to these features, Reality Composer Pro has added other exciting features this year, such as video docking, the ability to deploy to iOS and macOS alongside visionOS, environment authoring, and lighting. To learn more about these topics, please check out the sessions Enhance the Immersion of Media Viewing in Custom Environments, and discover RealityKit APIs for iOS, macOS, and visionOS. These new features will help you make your 3D content interactive, and I can't wait to see what you build with them. Thank you and have a great WWDC.